Hi everyone, in this video I am going to discuss chapter 9.1. This section is about vectors in the plane, or in other words vectors in R2. R2 is the Euclidean two-dimensional space. Okay, right, so let's first try to figure out what is meant by a vector. So in xy plane, here I am having the origin and I pick some arbitrary point P x comma y. So this is a vector that is directed from origin to point P. So this is my initial point and this is going to be my terminal point. Then we denote the vector from O to P by OP. OP and vector is directed from O to P, so therefore we put an arrow like this. Sometimes we use some simple letters to denote vectors. For example, you can say the vector A is OP, or you can say vector v is going to be OP, like that. You can use simple letters to denote vectors and we underline those simple letters to denote that it is a vector. Okay, right. So, right. Now what is the vector OP? So, the vector from origin to the point P is denoted by OP and OP is written in this way, x comma y. So, this is the coordinates of point P. X is the x coordinate and y is the y coordinate. We say that x is the x component of the vector OP and y is the y component of vector OP. Another way that we write the vector OP is xi plus yj. I represents the direction of x and j represents the direction y. Actually, I and j are the unit vectors along x and y. We would come to the definition of the unit vectors later. So for a moment, let's think that I is a vector in the direction x and j is the vector in the direction of y. So by adding these two, we would get the vector OP. Okay. So when you are denoting vectors, you can use either of these two notations. Let's consider this example. I have given two vectors OA and OB. OA is x1i plus y1j and OB is x2i plus y2j. You can go with this notation or you can use the other notation. What is our other notation? It is OA is equal to x1 comma y1 and OB is x2 comma y2. Right. Now we would figure out how do we find AB and BA. This is how we find the vector AB. AB is given by OB minus OA. Okay. What is my vector OB? It is going to be x2 comma y2 and my vector OA is x1 comma y1. When we are subtracting two vectors, we would subtract x component separately and y component separately. So I would get x2 minus x1 comma y2 minus y1. Okay, I would show you an example. Suppose you have two vectors OA equals 1 comma 1 and OB equal to negative 2 comma 3. Then how do we find the vector AB? That is OB minus OA. So OB is negative 2 comma 3 minus 1 comma 1. I subtract 1 from negative 2, so I would get negative 3 and I subtract 1 from 3 and I would get 2. Okay, that's how we find AB. So how would we find BA? So when I'm coming from AB to BA, I just change the direction. So what I would have to do is BA is negative AB. So if you multiply the vector AB by negative sign, you would get vector BA. So it is going to be negative x2 minus x1 comma negative y2 minus y1. That is equal to x1 minus x2 comma y1 minus y2. Okay. Similarly, in this example, what is my vector BA? It is going to be negative AB, that is equal to negative 3 comma 2, and I would get 3 comma negative 2. Okay, right. Let's go through this example as well. In this case, I have given OA equals 3i plus 6j and OB equals 5i minus 3j. Now I would go with this notation. So then what is AB? Again, AB is equal to OB minus OA. OB is going to be 5 times I minus 3j minus OA is equal to 3I plus 6j. Then my I component is going to be 5i minus 3i would become 2i, and my j component would be 9j minus 9j, because I'm subtracting 6j from negative 3j. So in this case, 2 is my x component and negative 9 is my y component. You can denote this vector by 2 comma negative 9 as well. Okay, so if you consider the vector BA is going to be negative AB, so BA would be negative 2 comma 9. Okay, because if you multiply vector AB by the negative sign, you would get vector BA. I have mentioned a note here, that is, we can add vectors. Suppose you have two vectors, then you can add vectors and you can multiply vectors by scalars. Scalars in this course and calculus 3, we are taking scalars from the field of real numbers, so you can assume that scalars are real numbers. That means you can multiply a vector by any real number. Okay. Right, so let's consider this example. This is about scalar multiplication and vector addition. I have given two vectors v1 and v2. v1 is 2 comma 3, v2 is negative 1 comma negative 4. In part A, I have asked to evaluate v1 plus v2. v1 is 2 comma 3 and v2 is negative 1 comma negative 4. It is easy to evaluate the addition. Perform the component-wise addition. You are adding 2 comma 3 and negative 1 comma negative 4. If you add your x components, you are adding 2 and negative 1, so you would get 1. And if you add y components, you are adding 3 and negative 4, you would get negative 1. Okay, let's move into part B. Part B is about scalar multiplication. So you have to compute 3 times v2. So I'm going to multiply vector v2 by 3. So multiply each component by 3. So you would get negative 1 multiplied by 3, that is negative 3. Negative 4 multiplied by 3, that would be negative 12. Let's move into the last part of this problem. In this case, you have to compute 3 times v1 minus 4 times v2. First, I would plug v1 and v2 to this expression. v1 is 2, 3 minus 4 times v2 is negative 1, negative 4. First, I would perform the scalar multiplication. So what I would get is 3 multiplied by 2, that would become 6, 9, minus, then I would multiply my vector v2 by 4, so then I would get negative 4, negative 16. Now I would subtract these two vectors, so then I would get 6 minus 4, that would become, or first I would perform multiplication by the negative side, so this would become positive, and this would become 4, and the y component would become 16 when I'm multiplying by negative sign. Now I would perform the addition. I would do the component wise addition. So if I add my x components, I would get 10, and if I add y components, I would get 25. This is the vector 3 v1 minus 4 times v2. Let's move into the next example. I have given two vectors v1 and v2. I have asked you to find lambda and mu such that lambda v1 plus mu v2 equals negative 1, 2. Okay, so what is lambda v1 plus mu v2? You are multiplying the vector v1 by lambda, and you are multiplying vector v2 by mu. First I would perform the scalar multiplication, so I would get lambda, lambda plus, if you multiply negative 2 by mu, you would get negative 2 mu, and if you multiply 1 by mu, you would get mu. Okay, so what I would have is, now I can perform the addition. So my x component would be lambda minus 2 mu, and my y component would be lambda plus mu. Okay, so, and I have given that lambda v1 plus mu v2 equal to negative 1, 2. So lambda v1 plus mu v2 equal to negative 1, 2. So I computed lambda v1 plus mu v2. That's going to be lambda minus 2 mu, lambda plus mu. And it is going to be negative 1, 2. Okay, right. Next, I can equate x components. On my left hand side, my x component is lambda minus 2 mu. And on my right hand side, my x component is negative 1. Similarly, on my left hand side, my y component is lambda plus mu, and on my right hand side, my y component is 2. So if I equate them, I have two equations. My first equation is lambda minus 2 times mu is going to be equal to negative 1, and lambda plus mu is going to be equal to 2. Okay, now I have two equations that contains lambda and mu, so I can evaluate the values of lambda and mu. I would call this equation to be equation number 1, and this equation to be equation number 2. So if I subtract 1 from 2, I would get 3 mu is equal to 3, and this gives me mu equals 1. Okay, right, now I know the value of mu, so I would use either of these two equations to find the value of lambda. So lambda plus mu, that is equal to 1 equals 2. This would give me the value of lambda equals 1. Okay, right. Next we would move to define the norm of a vector. Norm of a vector is the length of a vector. Suppose we have any arbitrary vector v equals xy. So note that this is a vector that connects origin and the point x comma y. Then the norm of this vector v is given by square root of x square plus y square. This is intuitive because we know that the norm is length, and from the Pythagorean theorem you can show that the length of that vector v is given by this formula. Okay, right. Let's consider this example. I have given two vectors and I have asked you to evaluate norms of v, u and u plus v. First we would focus on vector v. So what is the norm of vector v? That is the square root of 3 square plus negative 1 square. So you would get a square root of 10. What is the norm of vector u? That would be a square root of negative 2 square plus 1 square, and we would get a square root of 5. Okay. What is u plus v? My last part is to evaluate the norm of u plus v. What is u plus v? U plus v is, if I do component wise addition, I would get 1 comma 0. Okay. If I add 3 and negative 2, I would get 1. If I add negative 1 and 1, I would get 0. So the norm of u plus v is going to be square root of 1 square plus 0 square, and that should give me 1. Okay, right. Next, we would move into triangle inequality. So triangle inequality would give us a nice relation about the norm of addition of two vectors and norm of the two vectors. Okay, so suppose u and v are any arbitrary vectors in the plane, then this inequality holds. Then the norm of u plus v is going to be less than or equal to norm of u plus norm of v. Okay, it is clear from our previous example as well. If you consider the norm of u plus v, you have 1, but if you add the norm of u and norm of v, you would get something bigger than 1. Okay, alright. In general, triangle inequality is valid for three-dimensional vectors, that is, vectors in space, and also triangle inequality would hold for n-dimensional vectors as well. Okay, right. My next definition is the unit vector. Now we know how to write a vector and how to add vectors, how to multiply a vector by scalars and those stuffs. Now unit vector is the vector of length 1. Okay, so suppose I give some vector for you, then you can find a unit vector along the given vector. Suppose v is any arbitrary vector, then we can define the unit vector in the direction of v by this. So what you have to do is divide the given vector by the norm of that vector. Okay, so geometrically, suppose you have some vector like this, vector v, and you are finding a vector that is having length 1. So this is going to be the unit vector. You are dividing vector v by its norm. Okay, right. So let's consider this example. I have given two vectors and I have asked you to find the unit vectors along v, u and u minus v. Right. First we would find the unit vectors along v and u. Unit vector along v is given by v divided by the norm of v. Okay. So what is my vector v? It is going to be -3, -1, and I have to divide by its norm. Norm of vector v is given by -3 square plus -1 square root, and I would get 1 over the square root of 10, -3, -1. Okay, right. Next we would find the unit vector along u. So what I have to do is I have to divide my vector u by the norm of vector u. Vector u is going to be 2, 4, and then I would divide vector u by 2 square plus 4 square. That is the norm of vector u. So I have 2, 4 divided by 2 square would be 4 and 4 square would be 16. I would get a square root of 18. Okay. Final part is to evaluate the unit vector along u minus v. So what is u minus v? So I know the vectors u and v. So first I would evaluate u minus v. U minus v is going to be 2, 4 minus v is going to be -3, -1, and if I do the subtraction I would get 5, 5. Okay, because I'm subtracting -1 from 4, so I would get 5, and I'm subtracting -3 from 2, again I'm getting 5. Now what is the unit vector along u minus v? It is given by u minus v divided by the norm of u minus v. U minus v is going to be 5, 5, and norm of u minus v is going to be 5 square plus 5 square root. So I have 1 over the square root of 50 times 5, 5. Okay, so I note that 1 over square root of 50 is the scalar. If you multiply the vector 5, 5 by this scalar, you would get a vector whose length is 1. Okay, right. And then I would put another remark about I and j. I is the unit vector along the positive direction of x-axis, and j is the unit vector along the positive direction of y-axis. Okay, so if I ask a question like this, so this is my two-dimensional plane, and if I mark a point somewhere here, say 5 comma 0, what is this vector then? So then I would call this vector to be v. Then in this case, v is going to be 5 times I, because I know that the vector whose magnitude 1 is going to be I. So, and the vector v has length 5, so v is going to be 5 times I. Okay, that's why at the beginning I mentioned that if you are having point x comma y, that vector is going to be xi plus yj. Okay, right. So this is what I need to talk about chapter 9.1. In the next video, I would go through chapter 9.2.